Yes, I welcome you all for the continued session on some basic concepts of chemistry. This is going to be the last session as far as some basic concepts of chemistry is concerned, dear students. ಆತ್ಮೀಯ ವಿದ್ಯಾರ್ಥಿ ವೃಂದಕ್ಕೆ ಹೃತ್ಪೂರ್ವಕವಾದಂತಹ ಸ್ವಾಗತವನ್ನು ಕೋರ್ತಾ ನಾನೀಗ ಮುಂದುವರೆದ ಭಾಗದಲ್ಲಿ ಇದ್ದೀನಿ. ಒಂದಿಷ್ಟು ಸೆಷನ್ಗಳಲ್ಲಿ ಕಳೆದ 4 ಸೆಷನ್ಗಳಲ್ಲಿ ಒಂದಿಷ್ಟು ಮಾಹಿತಿಯನ್ನು ನಾವು ಹಂಚಿಕೊಂಡಿದ್ದೀವಿ ಅಂತ ನಾನು ಅಂದ್ಕೊಳ್ತೀನಿ. ಆ ನಿಟ್ಟಿನಲ್ಲಿ ಪ್ರಾಮಾಣಿಕ ಪ್ರಯತ್ನ ನನ್ನ ಕಡೆಯಿಂದ ಆಗಿದೆ ಅಂತ ಭಾವಿಸ್ತಾ ತಮ್ಮೆಲ್ಲರಿಗೂ ಮತ್ತೊಮ್ಮೆ ಈ ಸೆಷನ್ನಲ್ಲಿ ಒಂದಿಷ್ಟು ಮಾಹಿತಿ ಸಿಗಬೇಕು ಅನ್ನೋ ನಿಟ್ಟಿನಲ್ಲಿ ಪ್ರಾಮಾಣಿಕವಾದಂತಹ ಕೆಲಸ ಕಾರ್ಯಗಳನ್ನು ಮಾಡಲಿಕ್ಕೆ ಮುನ್ನಡೆಯಿಡ್ತಾ ಇದ್ದೀನಿ. ಆತ್ಮೀಯರೇ, ಯಶ್ ವಿ ಹ್ಯಾವ್ ಬೀನ್ ಡಿಸ್ಕಸಿಂಗ್ very basic aspects as far as the chemistry is being concerned. We started with the matters, types of matters, switched on to the properties of matters, and then basic units altogether. And we started the very basic concept as far as the elements, substance is concerned, atomic mass, molecular mass, and then we started the mole concept. A beautiful concept as far as the chemistry is concerned. ಇದು ನಿಮ್ಮ ಎಲ್ಲವರೆಗೆ ಕೆಮಿಸ್ಟ್ರಿ ಒಂದು ಅಧ್ಯಯನ ಭಾಗವಾಗಿರುತ್ತೋ ಅಲ್ಲೆಲ್ಲ ಮೋಲ್ ಕಾನ್ಸೆಪ್ಟ್ ಬಂದೇ ಬರುತ್ತೆ. So therefore please make sure that you got some awareness as far as that thing is concerned. Then we started about discussing about the stoichiometric calculations and then limiting reagent. Now I am into the reactions in solutions. Dear students, yes, solution. ಈಗ ಸಮಸ್ಯೆಗಳು ಬಂದೇ ಬರುತ್ತೆ. ಹಾಗಾದ್ರೆ ಸೊಲ್ಯೂಷನ್ ಅಂದರೆ ಏನು ಅಂತ ನಾನು ಫಸ್ಟ್ ಸೆಷನ್ನಲ್ಲಿ ಹೇಳಿದ್ದೀನಿ. ಮ್ಯಾಟರ್ ದರ್ ಆರ್ 2 ಟೈಪ್ಸ್ ಅಂತ, ಹೋಮೋಜೀನಿಯಸ್ ಆ್ಯಂಡ್ ಹೆಟ್ರೋಜೀನಿಯಸ್ ಅಂತ. 2 ಸಬ್ಸ್ಟೆನ್ಸಸ್ ಐ ಟೇಕ್, ಐ ಮಿಕ್ಸ್ ಇಟ್ ಅಪ್. ಅದು ಎರಡು ಮಿಕ್ಸ್ ಮಾಡಿದಾಗ ಒಂದು ಹೋಮೋಜೀನಿಯಸ್ ಅಂತ ಆದವಾಗ ಬೋತ್ ಲೂಸಸ್ ದೇರ್ ಐಡೆಂಟಿಟಿ, ರೈಟ್? ನಾವು 2 ಸಬ್ಸ್ಟೆನ್ಸಸ್ ಲುಕ್ಸ್ ಲೈಕ್ ಒನ್ ಪರ್ಟಿಕ್ಯುಲರ್ ಸಬ್ಸ್ಟೆನ್ಸ್, ರೈಟ್? ಸೊ ದರ್ಫೋರ್ ಇಟ್ ಲುಕ್ಸ್ ಲೈಕ್ ಒನ್ ಪರ್ಟಿಕ್ಯುಲರ್ ಸಬ್ಸ್ಟೆನ್ಸ್. Now that is called as homogeneous mixture having uniform concentration throughout. Such kind of matters are called as homogeneous mixture, and that particular homogeneous mixture is called as a solution. Solution is a homogeneous mixture of 2 or more substances. ನಾನೀಗ ಇದೇ ಚಾಕನ್ನು ಸಣ್ಣ ಸಣ್ಣ ಪೀಸ್ ಮಾಡಿ ವಾಟರ್ಲಿ ಹಾಕ್ತೀನಿ. ನೋ ವೇ ಇಟ್ ಈಸ್ ಸೊಲ್ಯೂಬಲ್ ಇನ್ ವಾಟರ್. ಇದು ವಾಟರ್ಲಿ ಕರಗಲ್ಲ. ದಿಸ್ ಇಸ್ ಕ್ಯಾಲ್ಶಿಯಂ ಕಾರ್ಬೋನೇಟ್. ಅದರ ಅಸ್ತಿತ್ವ ಹಾಗೆ ಉಳ್ಕೊಳ್ಳುತ್ತೆ. ಯು ಕ್ಯಾನ್ ಮೇಕ್ ದ ಪಾಯಿಂಟ್, ಸೊ ಇಸ್ ಕಂಟೈನ್ಸ್ ಸಮಥಿಂಗ್ ಎಲ್ಸ್ ಇನ್ ವಾಟರ್ ಅಂತ. ಎಲ್ಲೋ ಡರ್ಟ್ ವಾಟರ್ನಲ್ಲಿರುತ್ತೆ, ಯು ಕ್ಯಾನ್ ಮೇಕ್ ಎ ಪಾಯಿಂಟ್. ಒಂದು ಕಸಕಡ್ಡೆ ಬಿದ್ದುಕೊಂಡಿರುತ್ತೆ, ಎಸ್ ಇಟ್ ಈಸ್ ಎ ಹೆಟೋಜೀನಿಯಸ್ ಗೋಯಿಂಗ್ ಟು ಬಿ, ಬಟ್ ಐ ಪುಟ್ ಸಮ್ ಸಾಲ್ಟ್ ಇನ್ ಟು ದ್ಯಾಟ್, ಐ ಪುಟ್ ಸಮ್ ಶುಗರ್ ಇನ್ ಟು ದ್ಯಾಟ್. ಒಂದು ಗ್ಲಾಸಲ್ಲಿ ಅದು ನೀರು ಹಾಗೆ ಕಾಣಿಸುತ್ತೆ. 2 substances looking like one particular substance, one particular matter. So now such a substance is called as a solution. ಹಾಗಾದರೆ ಇಲ್ಲಿ ಮಿನಿಮಮ್ 2 ಸಬ್ಸ್ಟೆನ್ಸ್ಗಳು ಬೇಕು ಅಂತ ಆಯಿತು. Now for example, I take a beaker of this category, right? Now in that beaker I take water here. I add 1 spoon of sugar into that and I dissolve that. Completely it's being dissolved in that particular water. Now no way I have to call this as a water now. This is a solution. It contains 2 substances, one in small quantity, one in the large quantity. ನಾವು ಹೇಗೆ ಒಂದು ಸೊಲ್ಯೂಷನ್ ಮಾಡ್ತೀವಿ ಹೇಳಿ ನೋಡೋಣ. ಜ್ಯೂಸ್ ಮಾಡ್ತೀವಿ ಮನೇಲಿ, ಹೇಗೆ ಮಾಡ್ತೀವಿ ನೆನಪು ಮಾಡ್ಕೊಳ್ಳಿ. ಒಂದು ಗ್ಲಾಸ್ ತಗೊಳ್ತೀವಿ, ವಿಲ್ ಟೇಕ್ ವಾಟರ್ ಅಪ್ ಟು 3/4 of that glass and we add 1 spoon or 2 spoon of sugar and we'll just stir it, mechanical stirring, just applying the energy, making that dissolving process faster. Resulted thing is called as a solution. No way will take 1 glass full of sugar and we add 1 spoon of water. Sugar anta barlikke sadhya agalla. Now water is always going to be the large quantity. ಅಷ್ಟೇ ನೀವು ಶುಗರನ್ನು ಆ್ಯಡ್ ಮಾಡಿದ್ರೆ ಒಂದು ಸೊಲ್ಯೂಷನ್ ಆಗಲಿಕ್ಕೆ ಸಾಧ್ಯನೇ ಇಲ್ಲ. ಒಂದು ಪ್ರಮಾಣ ಇದೆ, ಅದಕ್ಕೂ ನಿರ್ದಿಷ್ಟ ಪ್ರಮಾಣದ ಮೀರಿದಾಗ ಶುಗರ್ ನೋ ವೇ ಇಸ್ ಗೋಯಿಂಗ್ ಟು ಬಿ ಡಿಸಾಲ್ವ್ಡ್ ಇನ್ ವಾಟರ್. ಮತ್ತೆ ನೀವು ವಾಟರ್ ಅಮೌಂಟನ್ನು ಜಾಸ್ತಿ ಮಾಡ್ತಾ ಹೋಗಬೇಕು. ಸೊ ದರ್ಫೋರ್ 1 will be in the larger quantity. Therefore very simple. Now the component present in the larger quantity is called as solvent ಅಂತ ಆಯಿತು. It's called as a solvent. Now The another component I need to add in the smaller quantity, that is called as solute. Altogether, dear students, it is called as solution. So solute plus solvent is called as a solution. I take salt, right? Okay, I start the process with sugar being sweeter, right? I take water, so it is sugar solution. It is sugar solution. I take salt, common salt, NaCl. I add into water, so it is salt solution. ಎರಡೇ ಕಾಂಪೊನೆಂಟ್ ಇರಬೇಕು ಅಂತಿಲ್ಲ. I take water, I add 1 spoon of sugar, I add 1 spoon of salt. The resulted mixture is going to be homogeneous perfectly. It's called as solution. Yes. So now, if you add sand into this, no way it results a solution, remember. Yes. I take a beaker, I add 1 spoon of sugar. I take one more beaker, I add 2 spoons of sugar. I take one more beaker, I add 5 spoons of sugar. ಎಲ್ಲ ಡಿಸಾಲ್ವ್ ಆದ ನಂತರ ನಾವು ಟೇಸ್ಟ್ ನೋಡಿದ್ರೆ there's a difference as far as the taste is being concerned. Now glass number 3, which contains 5 spoons of water, is much sweeter. So that means you can vary the level of solute ಅಂತ ಆಯಿತು. ಇದೆಲ್ಲ 3 ಸ್ಟೇಜಲ್ಲೂ ನಾನು ಫಿಕ್ಸ್ಡ್ ಅಮೌಂಟ್ ಆಫ್ ಸಾಲ್ಟನ್ನು ತಗೊಂಡಿದ್ದು, ವಾಟರನ್ನು ತಗೊಂಡಿದ್ದು. So therefore remember that thing. Now that is called as the concentration ಅಂತ ಕರಿತೀವಿ ನಾವು. The most of our reactions are being carried out in the solution phase. Usually we take the test tubes, and in that we'll make the solutions in that, and we'll carry out the reactions in that. So therefore we need to carry out the process as far as that concentration is concerned. ನಾನು ಎಷ್ಟು ಅಮೌಂಟ್ ಆಫ್ ಸೊಲ್ಯೂಟನ್ನು ನಾನು ತಗೊಂಡಿದ್ದೀನಿ ಹೇಳೋದನ್ನು ಆಧಾರವಾಗಿ ಇಟ್ಕೊಂಡು I need to carry out the reaction. Then only definitely I can come out with the proper amount of the products in the reaction. So that is called as concentration. So what is concentration now? The concentration is nothing but the quantity of a solute, the amount of a solute, right, which is present in known volume of solvent or known volume of solution, is called as concentration. You can vary the concentration, right? So depending on that thing, and there is a variety of methods of expressing that concentrations. We need to discuss that. So therefore I'll move on to the how do we express the concentration. Now concentrations are expressed in different manner. Now first one is mass percent. First one expressing the concentration. First one is mass percent. We call as W by W ಅಂತ ಕರಿತೀವಿ. Mass percent. Let's try to understand that thing later. The second one, it is called as molar fraction or mole fraction. Mole fraction. Number 3, it is called as molarity. It is called as a capital M designation. And last, as being said in the topic, it is molality. There are some more, but these are being shortlisted this year as far as that first topic is concerned. I need to stick to that thing also. So this is what is 4 important methods are being introduced this year in this topic. Let's try to understand what do these things mean ಅಂತ ಒಂದೊಂದೇ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ತಾ ಹೋಗಲಿಕ್ಕೆ ಪ್ರಯತ್ನ ಮಾಡೋಣ. Dear students, first I take mass percent. So as the name indicating, percent ಅಂದರೆ ಫಾರ್ ಎವರಿ 100 ಅಂತ ಅರ್ಥ. ಇಸ್ W by W ಅಂತ ನಾವು ತಗೊಳ್ತೀವಿ. ಅಂದರೆ ಬೈ ಮಾಸ್, ಎಲ್ಲವುದು ಬೈ ಮಾಸ್ ಅಲ್ಲೇ ಇರುತ್ತೆ. Now it's simply it's mass percentage mass of the solute. ನನಗೆ solute ಆಧಾರ, mass of a solute divided by mass of solution into 100. This is all about. So now this is mass of solute present in every 100 gram of solution is called mass percent of that solution ಅಂತ ಕರಿತೀವಿ. ಈಗ ನೋಡಿ, ಒಂದು ಎಕ್ಸಾಂಪಲ್ ತಗೊಳ್ತೀನಿ. 5% NaCl ಸೊಲ್ಯೂಷನ್ ಅಂತ ನಾವು ಕರಿತೀವಿ. ಹಾಗಂದ್ರೆ ಏನು ಅಂತ, ಇಲ್ಲೊಂದು ರಿಯೇಜೆಂಟ್ ಬಾಟ್ಲ್ ಇರ್ಬೋದು, ಅದರಲ್ಲೊಂದು ಸೊಲ್ಯೂಷನ್ ಇದೆ, ಇಟ್ಸ್ ಬಿಂಗ್ ರಿಟನ್ 5% NaCl ಅಂತ. ಡೆಫಿನೆಟ್ಲಿ it is telling something as far as that level of that amount of solute present. Andre 5 gram of NaCl present in 100 gram of that particular solution. Mass nalle ide idu, mass kuda 100 gram nalle ide. So therefore that's very important. It contains 5 gram. For example, 10% sugar solution, sucrose. ಇಲ್ಲಿ 10 gram of sugar is present in 100 gram of solution ಅಂತ ಅರ್ಥ. Very simple it is. Now I think let's try to calculate that also. One simple example I'll take it. How can you calculate, you can exhibit the percentage ಅಂತ. Right, I'll take like this. 5 gram of a salt, might be NaCl, is dissolved in 45 gram of water. Express the concentration of that solution in mass percent ಅಂತ ಹೀಗೊಂದು ಪ್ರಾಬ್ಲಮ್ ಇರ್ಬೋದು. See, the equation is there. ಮೊದಲೇ ಹೇಳಿದ್ದೀನಿ, ಅಲ್ಲೊಂದು ಇಕ್ವೇಷನ್ಸ್ ಇರುತ್ತೆ ಕೆಮಿಸ್ಟ್ರಿಯಲ್ಲಿ. ಒಂದು ಪ್ರಾಬ್ಲಮ್ ಅಂದರೆ ಹಾಗೆ ಒಂದಿಷ್ಟು ಪ್ಯಾರಾಮೀಟರ್ಸನ್ನು ಆ ಕನ್ಸರ್ನ್ಡ್ ಇಕ್ವೇಷನ್ ಟು ಪಿಕ್ ದ ರೈಟ್ ಇಕ್ವೇಷನ್ ಎಟ್ ದ ರೈಟ್ ಟೈಮ್. ದಟ್ಸ್ ಆಲ್ ಅಬೌಟ್. ಸೊ ದರ್ಫೋರ್ ಮಾಸ್ ಪರ್ಸೆಂಟ್ ಅಂದರೆ ಏನಾಗುತ್ತೆ ಅಂತ, ಮಾಸ್ ಆಫ್ ಎ ಸಾಲ್ಯೂಟ್ಸ್ ಬಿಂಗ್ ಗಿವನ್ 5 gram ಆಫ್ ಎ ಸಾಲ್ಟ್ ಅಂತ. ವೆರಿ ಗುಡ್, ಫೈನ್. ಮಾಸ್ ಆಫ್ ಸೊಲ್ಯೂಷನ್ ಹೇಳಿದ್ದಾರೆ, ಇಲ್ಲಿ ಸಾಲ್ವೆಂಟ್ ಈಸ್ 95. ನಾನು ಏನು ಮಾಡ್ತೀನಿ ಹೇಳಿ, ನಾವು ಇನ್ ಎ ಬೀಕರ್ ಆರ್ ಇನ್ ಎ ಗ್ಲಾಸ್, ಲೆಟ್ ಮಿ ಸೇ, ರೈಟ್, ಇಟ್ಸ್ ಆಲ್ರೆಡಿ 45 gram of water. I am adding 5 gram of salt. So what is the total amount? Solution is going to be formed after you add the solute. So isliye, so now total the mass of that solution is going to be 50 gram. So here 45 plus 5, it is 50. And what is for 100%? For every 100 ಇದು ಎಷ್ಟಾಗುತ್ತೆ ಅಂತ ಎಕ್ಸಿಬಿಟ್ ಮಾಡ್ತೀವಿ. ಇಲ್ಲಿ ಡಿನೋಮಿನೇಟರ್ 100 ಇರಬೇಕು ಅಂತೇನಿಲ್ಲ. ಸೊ 1/10, ಸೊ ದಟ್ ವಿಲ್ ಕ್ಯಾನ್ಸಲ್. ಸೊ ಇಟ್ ವಿಲ್ ಬಿ 10%, ಡಬಲ್ ಬೈ ಡಬಲ್. ಅಂದರೆ ಏನಾಯ್ತು ಹೇಳಿ ನೋಡೋಣ. 5 gram ಇನ್ ಟೋಟಲಿ 50 gram. ಹಾಗಾಗಿ 10 gram in going to be 100 gram of solution. That's how we exhibit the mass percent of a solution. So it gives the idea as far as the concentration is concerned, as far as the amount of the solute present in the solvent is concerned. So therefore I repeat once again, solution minimum it has to contain 2 components. ನಾವು ಯೂಶ್ವಲಿ ಈ ಯೂನಿಟಲ್ಲಿ ಏನು ಮಾಡ್ತಾ ಇದ್ದೀನಿ ಕೇಳಿದ್ರೆ, ಸಾಲ್ಯೂಟನ್ನು ಒಂದು ಸಾಲಿಡ್ ಆಗಿ ಡೀಲ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. ಸಾಲ್ಯೂಟ್ ಮೇ ಬಿ ಲಿಕ್ವಿಡ್ ಆಲ್ಸೋ, ಸಾಲ್ಯೂಟ್ ಮೇ ಬಿ ಗ್ಯಾಸ್ ಆಲ್ಸೋ. ಹಾಗೆಯೇ ಸಾಲ್ವೆಂಟ್ ಕೂಡ ಹಾಗೆ, ಸಾಲ್ವೆಂಟ್ ಮೇ ಬಿ ಸಾಲಿಡ್, ಸಾಲ್ವೆಂಟ್ ಮೇ ಬಿ ಲಿಕ್ವಿಡ್, ಸಾಲ್ವೆಂಟ್ ಮೇ ಬಿ ಗ್ಯಾಸ್. ಬಟ್ ಇನ್ ದಿಸ್ ಪರ್ಟಿಕ್ಯುಲರ್ ಸಿನಾರಿಯೋ, in this particular unit, so now what I do is I prefer the solvent in the form of liquid. I prefer the solute in the form of solid. Now there are variety of solutions. Definitely you are going to study all that category of the solution. Totally whenever there is a solid solvent, the 3 types of solute is present. There are 3 categories. Whenever is going to be the solvent is liquid, once again solute can be of 3 categories: solid, liquid, gas, 3 category, and also going to be under gas. So therefore 3 category. Totally 9 different types of solutions we have. We call it a solid solution, we call it a liquid solution, we call it a gaseous solution, and different examples also we can give it. But here at this moment, definitely we need to narrow down, saying that solvent, let's prefer water, or in the liquid form going to be, and here solute in the form of solid. So with that we have expressed the mass percent in terms of W by W, it's called as. So therefore simply it is the mass of a solute present in 100 gram of solution, not solvent, remember. So now after adding solute into solvent, solution is resulted. So ಹಾಗಾಗಿ ಒಂದು solute ಒಂದು solvent ಸೇರಿ ಬರುವಂತಹ ಒಂದು ಪ್ರಾಡಕ್ಟ್ ಇದೆಯಲ್ಲ, ಅಲ್ಲಿ ನಾವು ಸೊಲ್ಯೂಷನ್ ಅಂತ ಕರಿತೀವಿ. ನಾವು ದಟ್ ಇಸ್ ದಿ different way of expressing the concentration. Now another one is mole fraction. Number 2, whenever the solution is very dilute, and one pinch of small one or two crystals of NaCl is added into 100 ml of water taken in a beaker anta itkona, very dilute solutions. Avaga ನಾವು such kind of the concentration term is being used, that is called as mole fraction anta, right? Very simple. Naniga look at that, I take two things, component 1, ಯಾಕಂದ್ರೆ ಇಲ್ಲಿ first, usually in our traditional method, whenever you want to prepare the solution juice, ನೆನಪು ಮಾಡ್ಕೊಳ್ಳಿ, ನೀವು ಮನೇಲಿ ಜ್ಯೂಸನ್ನು ಹೇಗೆ ಮಾಡ್ತೀವಿ, ನಿಮ್ಮಮ್ಮ ಮನೇಲಿ ಅಡುಗೆ ಮನೆಯಲ್ಲಿ ಪ್ರತಿಯೊಂದು ಮನೆಯಲ್ಲಿ ಅಡುಗೆ ಮನೆ, ಇಟ್ಸ್ ಸಿಂಪ್ಲಿ ಎ ಸ್ಮಾಲ್ chemistry lab going to be, n number of activities are going on there, right? Burning process, preparing solutions, variety of such reactions is carrying on, right? Burning the fuel in the kitchen, right? There's a combustion of that particular hydrocarbon is going on. I said that, right? ಹಾಗೆಯೇ ಈಗ ಒಂದು ಜ್ಯೂಸ್, ಯಾರೋ ನಿಮ್ಮ ಮನೆಗೆ ಗೆಸ್ಟ್ ಬಂದರು, ಜ್ಯೂಸನ್ನು ಮಾಡಬೇಕು ಅಂತಿದ್ದಾವಾಗ ವಾಟ್ ಈಸ್ ದ ಟ್ರೆಡಿಷನಲ್ ಮೆಥಡ್? ವಿ ಟೇಕ್ ಎ ಗ್ಲಾಸ್, ವಿ ಟೇಕ್ ಎ ಕಂಟೈನರ್, ವಿ ಪೋರ್ ವಾಟರ್ ಫಸ್ಟ್ in the large quantity, then we add the salt whatever is going to be required manner, right? So ಹಾಗಾಗಿ anything which is going to be in the larger quantity, ನಾವು component 1 ಅನ್ನು ಪ್ರಿಫರ್ ಮಾಡ್ತೀವಿ, right? So going to be preferable one, the first one solvent going to be in the larger quantity, that is component 1 ಅಂತ ತಗೊಳ್ತೀವಿ, that is solvent usually, and component 2. So whatever the amount we have taken, anything we can express in number of moles, right? I have dealt with that thing, how to calculate number of moles, definitely by knowing the amount or mass of that substance taken and the molar mass being idea. So therefore I take it as an N1, I take it as an N2. N1 ಏನಾಯ್ತು ಇಲ್ಲಿ ಹೇಳಿ ನೋಡೋಣ? N1 is number of moles of component 1, usually solvent. Number of moles of component 2, it's going to be solute usually. Now usually the mole fraction is expressed as x anta prefer ಮಾಡ್ತೀವಿ. Now this is a mole fraction, it is x1 ಅಂತಂದ್ರೆ mole fraction of a solvent, it is the fraction of 1 mole, it is the number of moles of one component to the total number of moles present in the solution. It's a ratio. It's a ratio of number of moles of one component to the total number of moles of the components altogether, solid and solvent, present in the solution. So naniga x1 means it is the mole fraction of solvent. Mole fraction of solvent. ಇದೇನಾಗುತ್ತೆ ಹೇಳಿ? N1 divided by N1 plus N2. So N1 plus N2 is total moles present in a solution. Solution, the total mole ಏನಾಗಿರುತ್ತೆ ಹೇಳಿ? N1 plus N2. Very good. Now mole fraction of solute ನೋಡೋಣ ಈಗ. Mole fraction of solute. This is x2 ಅಂತ ಕರಿತೀವಿ ನಾವು. Look at that. In the denominator, total number of moles of solution, N2 usually the solute. So it is the ratio, means there is a numerator, there is a denominator, ratio of number of moles of a component. ಇಲ್ಲಿ ಎರಡು ಕಾಂಪೊನೆಂಟ್ ತಗೊಳ್ತೀವಿ separate ಆಗಿ, right? And to the total number of components present in the solution. Look at that, mole fraction of the solute is moles of solute divided by moles of solute plus moles of solvent, right? ಹಾಗೇನೆ mole fraction of solvent ಏನಾಗುತ್ತೆ ಹೇಳಿ? moles of solvent in the numerator, right? N1 ತಗೊಂಡೆ, and the moles of solvent N1 plus moles of solute altogether. So this is what is the way we will calculate, okay? Now there are different categories with mole fraction of A, mole fraction of B, or x1, x2, xa, xb ಅಂತಂದು ಕೂಡ ನಾವು ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಮಾಡ್ಬೋದು. A ಅನ್ನು ನಾವು ಸಾಲ್ವೆಂಟಿಗೆ ತಗೊಳ್ಬೋದು, B ಅನ್ನು ಸಾಲ್ಯೂಟಿಗೆ ತಗೊಳ್ಬೋದು. there is a different methods altogether. Now remember that thing, fraction ಅಂತ ಕರೆಯೋದೇ ಹಾಗಾಗಿ. Here always N1 plus N2 is bigger than N1. ಇದು total moles, number of moles present in solution. So here N1 plus N2, the present in denominator in both the cases is going to be bigger. ಹಾಗಾಗಿ value varies from 0.1 to 0.99 ವರೆಗೆ ವೇರಿಯೇಷನ್ ಆಗ್ಬೋದು. 0.1 to 0.9. ಸೊ ಇಟ್ ಈಸ್ ಲೆಸ್ ದೆನ್ 1. ಎರಡನ್ನು ಸೇರಿಸಿದವಾಗ the amount should be 1. Therefore, remember that if you add these two, x1, I mean mole fraction of solvent plus mole fraction of solute going to be 1. That means if you know one term in this equation, you can calculate another one. Or you can express like that, xa plus xb is equal to 1. So therefore, if you know the mole fraction of solvent, definitely you can calculate the mole fraction of another component. Okay, or there could be 3 components or 4 components and so on. So it is no unit at all, right? Now mass percent anta bardvalla, but it has no unit, simply a number going to be, that's it, in terms of fraction. Okay, so therefore now I'll move on to the another way of expressing the concentration, called as molarity. Number 3. So we are discussing different methods altogether in expressing the concentrations. Now number 3 is the molarity. Right? Molarity we designate as capital M here. It's very simple. It's the number of moles of a solute present in 1 liter of a solution. So ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ ಅಂತ ಕೇಳಿದ್ರೆ, I'll take M is equal to number of moles of solute, moles of a solute, a substance, divided by volume of the solution in liter. Volume of solution in liter only. I'll give some examples. Let's make the point clear. So now how many moles of solute we have taken? The moles alli irbeku calculation. Divided by volume of the solution. ಎಷ್ಟು ವಾಲ್ಯೂಮ್ ತಗೊಂಡಿದ್ದೀವಿ? 1 liter. Definitely done. So therefore let's see example. ಈಗ we'll express in different ways. ನೋಡಿ ಈಗ example 1m NaOH solution ಅಂತ ಇಟ್ಕೋಣ. 1m NaOH simple written. NaOH ಅಂತ ಬರೆದ್ರೆ no way it gives any idea. ಒಂದು reagent bottle ಅಲ್ಲಿ 1m NaOH ಅಂತ ಬರೆದ್ರೆ it gives large amount of ideas as far as the concentration level is concerned, the amount of the solute is being taken. ಆದರೆ 1m ಅಂದರೆ ಏನು ಅಂತ, 1m ಅಂದರೆ ಏನಾಗಬೇಕು? ಅಕಾರ್ಡಿಂಗ್ ಟು ದಿಸ್ ಇಕ್ವೇಷನ್ ಇಲ್ಲಿ 1 ಇರಬೇಕು, ಇಲ್ಲೂ ಕೂಡ 1l ಇರಬೇಕು. ವೆರಿ ಸಿಂಪಲ್. ದೆನ್ ಓನ್ಲಿ ವಿಲ್ ಗೆಟ್ ದಿಸ್ ವ್ಯಾಲ್ಯೂ ಆಸ್ 1. ದಟ್ ಮೀನ್ಸ್ 1m NaOH ಅಂತಂದರೆ ಇಟ್ ಕಂಟೇನ್ಸ್ 1 mole of NaOH in 1 liter of solution. So what is 1 mole of NaOH? 23 plus 1 24 plus 16 40. ಅಂದರೆ ನೀವು 40 ಗ್ರಾಮ್ ಆಫ್ NaOH ಅನ್ನು ಡಿಸಾಲ್ವ್ ಮಾಡಿದ್ದೀರಿ. ಸೊ ಓವರ್ ಆಲ್ ದ ವಾಲ್ಯೂಮ್ ಆಫ್ ಸೊಲ್ಯೂಷನ್ ಗೋಯಿಂಗ್ ಟು ಬಿ 1 ಲೀಟರ್. ನಾವು ಇದಕ್ಕೆ ಎಸ್ ವಿಲ್ ಯೂಸ್ ದ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಫ್ಲಾಸ್ಕ್ ಆ್ಯಂಡ್ ಒಂದು ಮಾರ್ಕ್ ಇರುತ್ತೆ, ಅಲ್ಲಿ ಅವರಿಗೆ ಡೈಲ್ಯೂಟ್ ಮಾಡ್ತಾ ಹೋಗ್ತೀವಿ ವಾಟರ್ನಲ್ಲಿ. ನಾವು ದಿ ವಾಲ್ಯೂಮ್ ಆಫ್ ಸೊಲ್ಯೂಷನ್ ಗೋಯಿಂಗ್ ಟು ಬಿ 1 ಲೀಟರ್. ಸೊ 1m of HCl, for example, 1 mole of HCl being dissolved in 1 liter present in 1 liter of solution. That's it. Ultimately the final volume of the solution should be 1 liter. That's it. For example, let me say, so 1m NaCl solution 58.5 gram. 1 mole ಅಂದರೆ ಎಷ್ಟು ಅಂತ we have studied. It contains that many particles. ಈಗ ನೀವು ಈ ಸೊಲ್ಯೂಷನ್ನಲ್ಲಿ 1 mole ತಗೊಂಡಿದ್ದೀರಿ, ಡೆಫಿನೆಟ್ಲಿ ಅವುಗಳ ನಂಬರ್ ಆಫ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಇರಲೇಬೇಕು. Okay, now similarly how to prepare 2m NaOH? Yes, I'll change it here. 2m ಅನ್ನು ಹೇಗೆ ಮಾಡ್ತೀರಿ ಅಂತ. 2m ಬರಬೇಕಿದ್ರೆ ಇಲ್ಲಿ 2 ಬರಬೇಕು ಅಂತ ಏನಾಗಬೇಕು ಹೇಳಿ? You have to take the values are going to be 2 here. 2 by 1. Volume of solution going to be 1 liter. 1000 ml I said. So 1 dm cube. So that means it contains 2 mole of NaOH in 1 liter is fixed. The volume of solution is going to be fixed here, 1 liter. So I vary the solute amount quantity, and with respect to that volume is the concentration level is changed. Similarly, I take 0.1m. I take 0.1 m NaOH. How to prepare 0.1 m ಅಂತ ಇಲ್ಲಿ ನೋಡಿ ಮೊಲಾರಿಟಿಲಿ 0.1 ಬರಬೇಕು. So this is fixed 1 liter. I'll take it is, for example, 1 liter only. It's dissolved in 1 liter. So here 0.1 mole. That means in numerator, look at this. Very simple. 0.1 mole of NaOH present in 1 liter. Look at now. Now 1 mole ನಮಗೆ ಎಷ್ಟು ಅಂತ ಗೊತ್ತಿದೆ NaOH. 1 mole of NaOH is 40 gram. Therefore, what is about 0.1 mole? 1 mole is equal to 40 gram. Therefore, 0.1 mole is equal to 40 by 1 into 0.1. It is 4 gram or 4.0 gram of NaOH present in 1 liter will give you what? 0.1 m of solution. So, molarity of a solution is the number of moles of solute present in 1 liter of a solution. It's a very simple aspect. It is denoted by the symbol m ಅಂತ ಕರಿತೀವಿ ನಾವು, right? So now look at that. ಇಲ್ಲಿ ವಾಲ್ಯೂಮ್ ತಗೊಳ್ಳೋದ್ರಿಂದ, so volume definitely proportional to the temperature. There is a variation with respect to the temperature. Therefore, with respect to temperature, there is some changes in the molarity being expressed. Therefore, when the constant temperature ತಗೊಂಡ್ರೆ ಮಾತ್ರ this molarity, this is not independent of temperature. This is dependent on the temperature, right? So there is a variation with respect to the changes in the temperature, but you just remember this is how we'll express the molarity. Now I take one simple example in this case, how to calculate anta. So now I prefer NaOH only, okay, right? Now we know the equation also, how to calculate that. Okay, now what I do is now 4 gram of NaOH is present in, is dissolved in 250 ml of solution. What is the molarity of that particular solution, right? That's the equations I need to use it, remember, dear students. Okay, so therefore equation is what? Mass, I mean mole, the mass of the solute is expressed in terms of mole. Therefore, mole, number of moles of solute divided by definitely going to be what? In terms of volume of solution, right, in liter. Okay, so therefore this is what is the important stage to calculate that. Now, okay, now I'll take calculate the molarity. Calculate the molarity. I take 4 gram of NaOH present in 250 ml. Very simple. Now this is molarity is equal to number of moles of solute divided by volume of solution in liter. I take PL anta bariyona. Mole we have studied. What is mole? Mass W divided by molar mass of that particular substance divided by VL anta. What is W? W is refers to what? NaOH. Therefore 4 divided by molar mass of NaOH, we have studied that, 40, divided by volume of solution in liter. What's the volume of solution? 250. It is given in ml, but what about 1000 ml means 1 liter. Divided by 1000 you have to carry out. Divided by 1000 you have to carry out. Therefore, look at this, 4 by 40, I'll do this, divided by what? 0.25 liter it is going to be. 0.25 liter. Therefore, it is so now 1 by 10, right? So you can vary the amount of solute, and with respect to that you can calculate. You can change the solute in the place of that. You can take the sucrose, you can take the glucose, variety of that thing, definitely you can calculate. Now sometimes in the molarity equation is that to calculate the molarity of different solutions together, prepare the solutions of the other molarity. One particular concentration is given, we need to calculate the different concentration of the same solution. With respect to that, there is a formula to calculate, or one particular solution of having one certain molarity is diluted with water, then what is the resulted the solution molarity is going to be? It's an equation, you have to remember this, m1 v1 is equal to m2 v2. And this kind of equation we use it in the experimental purpose called as a titrations anta, where we use burets, pipettes, etc. Concentration of one solutions will be known, another solution will be unknown. Avaga ನಾವು unknown concentration ನಾವು ಕಂಡುಹಿಡಿತೀವಿ by doing the reaction and noting down the end point also. And that time we'll use the equation called as m1 v1 is equal to m2 v2. ಹಾಗಾದರೆ m1 v1 ಗಳು ಏನು ಅಂತ? m1 ಅಂದರೆ ಒಂದು ಸೊಲ್ಯೂಷನ್ದ ಇನಿಷಿಯಲ್ ಕಾನ್ಸಂಟ್ರೇಷನ್, ಆ್ಯಂಡ್ m2 ಅಂತಂದರೆ ಆಫ್ಟರ್ ವಾಟ್ ಯು ಹ್ಯಾವ್ ಮೇಡ್ ದ ಚೇಂಜಸ್ a new solution is resulted. I have taken 100 ml of one particular solution ಇಟ್ಕೋಣ. Look at that, I have taken yes, I have taken 0.1 m of NaOH solution. Okay, now I add some more amount of water here. I have doubled the volume ಅಂತ ಇಟ್ಕೋಣ. This is V1 and this is V2 after you have added the water. So with respect to that, concentration ಕೂಡ changes ಆಗಬೇಕು. Therefore, now M2 ಅಂತಂದರೆ the molarity of the new solution after you have done some changes. V1 initial volume, this is what the initial volume, and this is the final volume going to be after you have mixed up that amount of solution with a definite volume of water, right? So now with this kind also we definitely use this equation to calculate a variety of the concentration of the solutions on dilutions. Now dilution anta word ನಾನು ಯೂಸ್ ಮಾಡಿದೆ. Now I think I need to make that concept clear. Dilution means adding water into solution. I have 1 m NaOH solution. ನನಗೆ 0.5 m solution of NaOH ಬೇಕಾಗಿರುತ್ತೆ. I have 500 ml of that particular solution. ನಾನು ಎಷ್ಟು ವಾಟರ್ನ ಆ್ಯಡ್ ಮಾಡಿದ್ರೆ that solution itself will become 0.5 m anta. Now that definitely will get the idea from this, right? Now that's how we'll use this equation. I'll take one particular problem. Now calculate the volume of water to be added anta, to be added, how much of volume to be added. Calculate the volume of water to be added to 500 ml of okay, 0.5 m NaOH to make it decinormal. I use the word decinormal. Deci means 10 raised to minus 1, decimolar. To make it decimolar. Deci andre 0.1, 10 raised to minus 1. 0.1 decimolar means 0.1 m. Just I will solve this. Now for this basic equation is going to be m1 v1 is equal to m2 v2. ನಮಗೆ ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ ಅಂತ ನೋಡೋಣ. ಇಲ್ಲಿ 0.5 m ಸೊಲ್ಯೂಷನ್ ಕೊಟ್ಟಿದ್ದಾರೆ, 500 ml ಅನ್ನು ಕೊಟ್ಟಿದ್ದಾರೆ. 500 ml is supposed to be given now, okay, to make it decimolar. So m2 is also given now. So therefore I'll write it now based on this, right? m1 is given 0.5 m. Okay, now v1 is given 500 ml, right? m2 is also given, this is 0.1 m. So ನನಗೆ v2 ಗೊತ್ತಿಲ್ಲ. I need to calculate now. ನಂತರ ಎಷ್ಟು ವಾಟರ್ನ ಆ್ಯಡ್ ಮಾಡಬೇಕು ಅಂತ ಕೂಡ ನಾವು ಕಂಡುಹಿಡಿಬೋದು. The beauty of these equations, I'll come to that thing. Now therefore look at this, according to this equation, m1 0.5 into 500 is equal to 0.1 into v2, right? Therefore v2 is equal to, right? So now 0.5 into 500 divided by 0.1. There is, therefore answer is 2500 ml ಅಂತ ಆಯಿತು. 2500 ml. This is V2 final volume. It's a new solution ಆಯಿತು. You have added something, you have added water into that, the resulted solution volume has changed to 2500 ml or 2.5 liter it is. Earlier it was only 500 ml. Now namigenu ಮಾಡಬೇಕು, ಎಷ್ಟು ವಾಟರ್ ನಾವು ಕ್ಯಾಲ್ಕುಲೇಟ್ ದ ವಾಟರ್, ದಿ ವಾಲ್ಯೂಮ್ ಆಫ್ ವಾಟರ್ ಟು ಬಿ ಆ್ಯಡೆಡ್, ಎಷ್ಟು ಆ್ಯಡ್ ಮಾಡಿದ್ರೆ ಅದು ಆಟೋಮೆಟಿಕಲಿ 0.1ಗೆ ಕನ್ವರ್ಟ್ ಆಗುತ್ತೆ, 0.5 m ಇರೋದು ಅಂತ. ದೇರ್ಫೋರ್ ವಾಟರ್ ಟು ಬಿ ಆ್ಯಡೆಡ್ ಈಸ್ V2 final volume minus V1 2500 ml minus 500 ml. So therefore the answer is, look at this, 2000 ml, or this is equal to 2 liter. ನೀವು 500 ml ಆಫ್ ನಿಮಗೆ ಸೊಲ್ಯೂಷನ್ಸ್ ಕೊಟ್ಟದ್ದಿದೆ, ಅದಕ್ಕೆ ನೀವು 2 ಲೀಟರ್ನ ಆ್ಯಡ್ ಮಾಡಿದ್ರಿ ಕರೆಕ್ಟಾಗಿ ಅಂತಂದರೆ ಆ 0.5 m ಇರುವಂತಹ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಆಟೋಮೆಟಿಕಲಿ ಇಟ್ ಈಸ್ ಕನ್ವರ್ಟೆಡ್ ಇಂಟು 0.1 m. This is what is the application of this kind of equations, and variety of, you can calculate the concentration also. One particular solution namiga 500 ml of 0.5 m is mixed with 1 liter of water. So what is the concentration, what is the molarity of that new solution? aವಾಗ ನೀವು V2 ಕೊಟ್ಟಿರ್ತಾರೆ, ರೈಟ್? 500 ಇತ್ತು, 1000 ಅನ್ನು ಆ್ಯಡ್ ಮಾಡಿದೆ, 1500 after the resulted solution volume ಆಯಿತು, M2 you have to calculate. So in that way this application is highly useful, remember. Now finally I need to conclude this thing by taking the one more term for expressing the concentration, that is called as molality. Number 4 is molality. Molality. Yes. Now molality ಅಂತಂದರೆ small changes here. It is defined as number of moles of solute. ನಾವು molarity ಹೀಗೆ ಹೇಳಿದ್ದೀವಿ, a small m usually will be preferred, small m here. Number of moles of solute molarity ತಗೊಂಡಿದ್ದೀವಿ, ಇಲ್ಲೂ ತಗೊಳ್ತೀವಿ. ಅದರ ಡಿಫ್ರೆನ್ಸ್ ಏನು ಅಂತ ನಾನು ಹೇಳಿದೆ, the molarity is temperature dependent. ನೀವು ಟೆಂಪ್ರೇಚರ್ ವೇರಿಯೇಷನ್ ಮಾಡಿದಾಗ ವಾಲ್ಯೂಮ್ ವೇರಿಯೇಷನ್ ಆಗೋದ್ರಿಂದ there is a changes as far as the concentration is concerned ಅಂತ. ಬಟ್ ಇಲ್ಲಿ ನಾವೇನು ಮಾಡ್ತೀವಿ, ಮೊಲಾರಿಟಿ m ಅಂತಂದರೆ ನಂಬರ್ ಆಫ್ ಮೋಲ್ಸ್ ಆಫ್ solute, definitely number of moles of solute, mole of solute divided by volume of solution in liter ತಗೊಂಡಿದ್ದೀವಿ ಮೊಲಾರಿಟಿಲಿ. ಬಟ್ here small changes, the mass of solution in kg. Mass of solution in kg will prefer, right? So mass of yes, so therefore molality is defined like this. So it's being the equation says like this, m is equal to number of moles of solute divided by mass of solvent in kg. Mass of solvent in kg, that's what you have to remember. So now number of moles of solute going to be numerator here, not the mass of solution, it's the mass of solvent, fixed mass of solvent, 1 kg of water. So therefore I'll give the example how to prepare 1 m anta. 1 m small m, any watch, capital M usually molarity ಗೆ ನಾವು ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡ್ತೀವಿ. ಇಲ್ಲಿ ಆನ್ಸರ್ should be 1 ಬರಬೇಕಿದ್ರೆ ಇಲ್ಲಿ ಒಂದೇ ಇರಬೇಕು. therefore numerator should be 1 mole of NaOH present in, dissolved in what? In the denominator it is 1 kg of water. 1 kg of, that is a fixed thing. But molarity after mixing the volume of solution should be 1 liter. So remember that two aspects usually. So here solvent is fixed quantity 1 kg. Again, for example I need to prepare 0.1 m of NaOH. ಅಂದರೆ ಇಲ್ಲಿ 1 m ಅಂದರೆ ಏನು, 1 mole ಅಂದರೆ ಏನು ತಗೊಳ್ಬೇಕು ಹೇಳಿ? I have to take 1 mole of NaOH in terms of molar mass, that is 40 gram of NaOH. 0.1 m ಇಲ್ಲಿ LHS ಅಲ್ಲಿ 0.1 ಆನ್ಸರ್ ಬರಬೇಕು ಅಂದರೆ in the numerator I have to take 0.1. The 0.1 mole in terms of mass, it is 4.0. 4 gram of NaOH should be dissolved strictly in 1 kg of water, and that ultimate the concentration of that solution will be a one molality ಅಂತ ನಾವು ಹೇಳ್ತೀವಿ, right? Therefore remember that. So now molarity and molality is entirely different, and therefore since the mass is involved, which is independent of temperature there, now this unit of expressing the concentration is once again not temperature dependent, it is temperature independent, right? So now these are the four ways of expressing the concentration terms all together in the solutions, as far as, because it's needed, we carry out n number of reactions in the solution media. Now there we'll have to express the concentration in the particular unit. So these are the sum of the units starting from mass percent, mole fraction, molarity and molality. This is what is the ending up of the beautiful unit called as some basics of chemistry. The students, from my point of view, wishing all the best in your future also. I hope you got the aspects as far as the some basic concepts is concerned. Yes, ಮತ್ತೆ ಹೇಳ್ತಾ ಇದ್ದೀನಿ ನಾನು, ಯಾವತ್ತೂ ಹಾಗೆಯೇ ವೇಕೃತೆ ವರ್ಧನೆ ನಿತ್ಯಂ ವಿದ್ಯಾಧನಂ ಸರ್ವಧನ ಪ್ರಧಾನಂ ಅಂತ. ಎಲ್ಲ ಸಂಪತ್ತುಗಳನ್ನು ನಾವು ಖರ್ಚು ಮಾಡಿದ ಹಾಗೆ ಅದು ಹಾಗೆ ಕರಗ್ತಾ ಹೋಗುತ್ತೆ, ಬಟ್ ವಿದ್ಯೆ ಮಾತ್ರ ಹಾಗಲ್ಲ. ನೀವು ಎಷ್ಟು ನಿಮ್ಮನ್ನು ಇನ್ವಾಲ್ವ್ಮೆಂಟನ್ನು ಮಾಡ್ಕೊಂಡು ಹೋಗ್ತೀರೋ ಅಷ್ಟು ಸಮೃದ್ಧಿ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ವೇಕೃತೆ ವರ್ಧನೆ ನಿತ್ಯಂ ವಿದ್ಯಾಧನಂ ಸರ್ವಧನ ಪ್ರಧಾನಂ ಅಂತ. ಎಲ್ಲ ಸಂಪತ್ತುಗಳಲ್ಲಿ ಶ್ರೇಷ್ಠವಾದಂತಹ ವಿದ್ಯೆ ನಿಮ್ಮದಾಗಬೇಕು. ಮುಂದಿನ ದಿನಗಳಲ್ಲಿ ಇನ್ನೂ ಹೆಚ್ಚಿನ ಶ್ರೇಯಸ್ಸು ನಿಮಗೆ ಬರಬೇಕು, ಹೆಚ್ಚಿನ ಮಾಹಿತಿ ನಿಮಗೆ ಸಿಗಬೇಕು, ವಿಜ್ಞಾನ ಕ್ಷೇತ್ರದಲ್ಲಿ ನಿಮ್ಮಿಂದ ಒಂದಿಷ್ಟು ಕೊಡುಗೆಗಳು ಬರಬೇಕು ಅಂತ ಹೇಳ್ತಾ, ತಮ್ಮೆಲ್ಲರಿಗೂ ಈ ಟಾಪಿಕ್ನಿಂದ ಸಮ್ ಬೇಸಿಕ್ ಕಾನ್ಸೆಪ್ಟ್ ಆಫ್ ಕೆಮಿಸ್ಟ್ರಿಯಿಂದ ಒಂದಿಷ್ಟು ಮಾಹಿತಿ ಸಿಗುವಂತಾಗಲಿ ಎನ್ನುವಂಥ ಆಶಯವನ್ನು ತೋರ್ಪಡಿಸ್ತಾ ಮತ್ತೊಮ್ಮೆ ತಮಗೆಲ್ಲರಿಗೂ ನಮನಗಳನ್ನು ಸಲ್ಲಿಸ್ತಾ ಈ ಸೆಷನನ್ನು ಮುಗಿಸ್ತಾ ಇದ್ದೀನಿ. ಥ್ಯಾಂಕ್ ಯು ಒನ್ ಆ್ಯಂಡ್ ಆಲ್.